Assalamu alaikum, everyone. Welcome to Mathematics with Shahab Yaqub. We are starting with the concept of P1, and this concept is related to three topics. That is quadratics, that is functions, and it's also related to differentiation. And the name of this topic is increasing, decreasing functions. So let's get started with the basic idea, and then we can get right to the past paper questions. So now let's say I draw a grid over here, and I draw the same grid. Let me just copy it. So that grid is also over here. And let me draw the grid somewhere over here and somewhere over here. Now let me draw a quadratic graph. So I have drawn a quadratic graph like this. I have drawn another quadratic like this. I have drawn a cubic like this and a cubic like this, and one cubic going this way and then going this way. Let me just make it a little bit. Okay. So let me just adjust it. Okay, that's perfect. Now what we see is that we see two quadratics and two cubic. The x coordinate, let's call it A. The x coordinate of the turning point, let's call it B. Let's call it C. Let's call it D. For some people, this is exactly the same thing that we did in class today. So I'm just reviewing it to get things started. Now, if I draw some lines with a positive slope, so this is a line with a positive slope, and the green line is with a negative slope. So this is positive slope. This is negative slope. And what we see over here is that this portion of the graph has a positive slope. Actually, positive is the red one. So this portion is positive. This has a positive slope. I'm just drawing some tangents. So let me just shift it a little bit. Let me draw another positive slope, and a positive slope between these two. So if I want to write what are the range of values for which the slope is positive, this is x is greater than A, this is x is lesser than B, this is x is greater than D, and x is lesser than C. And also over here, x lies between Q and R. This is all for the positive slope. When we talk about the negative slope, that is this portion over here to the left of the turning point. In this case, it's to the right of the turning point. In this case, it's between the two turning points. In this case, that's over here and that's over here. So let me write in green color the negative slope. This is x is less than A. This is x is greater than B. This is x lies between C and D. Over here, x is lesser than Q, x is greater than R. That means I'm interested in the positive, negative slope of a curve. I'm interested in gradient. Now, what exactly needs to be done is that if there is a positive slope, it means dy by dx is greater than 0. If there is a negative slope, and this means that dy by dx is less than 0. Why? Because dy by dx is gradient of tangent to the curve. So positive slope, dy by dx greater than 0. Negative slope, dy by dx less than 0. When it has a positive slope, we say it's an increasing function of x. X increases, y increases. X decreases, Y decreases. It's an increasing function. And when it has a negative slope, we say it's a decreasing function. In other words, when the question is asking about increasing function, what do? We make dy by dx greater than 0. When the question asks for decreasing function, what do? We make dy by dx less than 0. That is the basic idea, with naturally some spice added to it. Now, this is the past paper. These are different past paper questions. So let's start with question number 2. The first thing, the equation of a curve is this. Let me also get my highlighter ready. And let me choose this color. The equation of a curve is this much, which is y is equals to x squared minus 3x plus 2. Let me make it even more thinner. Find the set of values of x. That's another name for range of values of x, for which this thing is a decreasing function of x. So all you do is this. Y is equals to x squared minus 3x plus 4. And dy by dx, the first derivative, that is 2x minus 3. For decreasing, we will say dy by dx is less than 0. 2x minus 3 is less than 0. Therefore, 2x is less than 3. Therefore, x is less than 3 over 2. That means the original is a quadratic function. The first derivative, that is a linear expression or linear function. So when we are looking for this, it's a quadratic in which the coefficient of x squared is positive. That is the shape. So decreasing, it's to the left of turning point. Let's look over here. It has a positive coefficient of x squared. Decreasing is green color. It's to the left of turning point. So this original thing exactly matches with the algebra that's done over here. All good, all clear. Let's move on. Question number 2. In this case, it's question number 9 in the order, but this is question number 2. Now it says a curve has equation y is equals to fx. It is given that f prime x is this. So we don't know what the original function is, but the first derivative is quadratic. So the first derivative is quadratic, and we will soon learn integration. That means the original function is cubic. It's already given f prime x, the first derivative, that is 3x squared plus 2x minus 5. And they are asking, find the set of values of x for which f is an increasing function. Therefore, f prime x is greater than 0 for increasing function. In other words, 3x squared plus 2x minus 5 greater than 0. Middle term factorization, 3x squared plus actually minus 2x, 5 into 3. So minus 3x plus 5x minus 5 greater than 0. 3x minus 1 plus 5 bracket x minus 1 is greater than 0. X minus 1, 3x plus 5 greater than 0. Now, always remember, whenever you have a quadratic inequality, drawing a sketch based upon the concept of factorized form is a must. So this is mandatory, this is necessary, and there are many other words in different languages. So what we do is that we draw a horizontal line. We draw a curve like this. We mark the points, the roots. So the coefficient of x squared is positive. The coefficient of x squared is positive. That's why this is the shape. X minus 1 equals to 0. So therefore, the roots are 1 and the roots are negative 5 over 3. So this is negative 5 over 3. This is positive 1. We are interested in greater than 0. That is the region above the x-axis. That is this region. That is this region. Extreme right, extreme left, x is greater than 1 and x is lesser than -5/3. That is the answer. Now look over here. The original is cubic. Since this coefficient of x squared is positive, the coefficient of x cube is also positive. And we are looking for increasing. It's two separate inequalities. So let's go back. The coefficient of x cube is positive. It's starting from top right going till bottom left. Positive slope, two separate inequality, right of the bigger turning point, left of the smaller turning point. This is right, this is left. It exactly matches with this. So now this is all good, all clear. Let's move on. Now I need to make you understand a concept that is known as PSAE, perfect square algebraic expression. So this is perfect square algebraic expression. That means if there is a linear expression inside a bracket and there is a square on the outside, there are only two options that's possible. The first option is either it will give me a 0 or it will give me a positive value. It will give me a 0 for only one value. Why? We will soon see. For all other values, this expression, the square expression, will always be positive. In other words, it will never be negative. So let me write over here. That is, let me just double check if this is all good, all clear. Someone just said that the audio is a little bit weak or something. If it was, I think it would be getting stuck over here. So I don't think so. So now let me write this thing over here. That is this group, and we are talking about PSAE. So this concept, is it all good, all clear? That it can be positive, it can be negative, but it can be 0. It can be positive, but it will never be negative. All good, all clear? So now let's look at this. Let's say x plus 1 whole square. It can be 0. It can be positive. It will be 0 when x plus 1 equals to 0. Therefore, x is -1. For all other values, whether you put -1000 plus 1 after squaring, it will become positive. Whether you put 1,000,000 plus 1 after squaring, it will be positive. So it will only be 0 for one value. Why? Because it is linear. Another example, 2x plus 3 whole square. It will be 0 when the bracket is 0. So 2x plus 3 equals to 0. X is -3/2. Therefore, it will be positive for all other values of x. All good, all clear. Now let's apply this knowledge over here. And this question can be done in two different ways. It says the function f is such that fx is this, and this is the domain of the original function. This is the domain, the input values of the original function. And fx is given, a cubic. Obtain an expression for f prime x, and hence explain why. F is an increasing function. They're using the word explain. So you have to write it in English. Fx equals to 3x plus 2 whole cube minus 5. F prime x equals to 3 bracket 3x plus 2 power reduces by 1. What is the derivative of the bracket? That is 3. And -5, the derivative is 0. So therefore, what do we have? We have f prime x equals to 9 bracket 3x plus 2 whole square. For this domain, I have to prove that this will always be positive. So f is an increasing, basically prove that f prime x is always positive for x is greater than or equal to 0. That is the strategy. So now let me do method 1. That is based upon quadratics. And I need to sketch it. And this sketch will be based upon completing square method. But it's not completing square as yet because the coefficient of x is not 1. I have to make it 1. So let me write this thing as 9 bracket 3 common x plus 2/3 the whole thing square. That is 9 common. That is 9. That is x plus 2/3 whole square. That is 81 x plus 2/3 whole square plus 0. This is of the form y is equals to a x minus h whole square plus k. A is positive. That is the shape. H is 2/3 with a negative sign. So minus h is this thing. That is minus 2/3. Let me double check everything. Yes, it's all good. It's actually positive. And this is minus h. All good. And k is 0. So therefore, minus 2/3 comma 0. That is the coordinate of the turning point. That is the vertex. That is the stationary point. Now, if I draw this thing and this grid is there, and this is negative 2/3 comma 0. So let me just draw the grid over here. So this is negative 2/3 comma 0. That goes like this. Let me just grab it and make it touch the x-axis. So now over here, this point is negative 2/3 comma 0. That is the turning point. And this is the y-axis. This is the x-axis. This y is not y actually. This y is f prime x. We are drawing it for f prime x. So this thing is, if I just push it on the side, so this thing is f prime x that we are drawing for. The original function is cubic. The domain is x is greater than or equal to 0. That means if I start from here, this portion of the graph is positive. To the right of the turning point, at turning point, the gradient is negative. Right of turning point, it is positive. Right of 0, it is positive. So we can say that right of x value 0, which means x is greater than or equal to 0. The f prime x is positive. Since f prime x is positive, therefore the original function is an increasing function. That is the logic that we use. So now I have reduced it. Have a good look at it. So this is the explanation of question 6, in which there is English and there is math. And it's a mixture of both things because you have to do the explanation. Okay. So this thing is 1, is 2, all these people. So this thing is sent to you. Okay. Now this thing is all done. Let's use this method, PSAE, perfect square algebraic expression, also for this one. And then I'll ask you to try out one other question. So let me add a page. Let me add the same question right over here. And now I'm focusing on method 2 for the explanation. That is based upon PSAE, perfect square algebraic expression. F prime x, that is what? That is 9, 3x plus 2 whole square. So this is 9, 3x plus 2 whole square. And this format is perfectly fine. Now let me focus on this thing. That is right over here. So this thing right over here, that is 3x plus 2 whole square, can have a value of 0. It can have a value of positive. It will be 0 when 3x plus 2 equals to 0. Therefore, x is negative 2/3. But this is the domain. It's not part of the domain. But this value, it's not part of domain. X is greater than or equal to 0. So we are carefree now. Therefore, for all other values, the bracket 3x plus 2 whole square is positive. Even if I multiply it with 9, since that is a positive value, it will be positive. Therefore, f prime x will be positive. Therefore, the function will be an increasing function for this particular domain. All good, all clear? That is what I have used. So now the second method. So PSAE method for the same question. So now this is all good, all clear. So now let me share a question with you. And I would like you to try it out. So let me also share this image over here with you people. You can have a look at this image. This particular one, both images are there. And then you can try out this particular question, which you see on the screen. So let me pause the recording first. So everyone now have a look at the solution of this particular question. The question says fx is such and such. So fx equals to 3 bracket 2x plus 5 raised to power of -1. Now, when I differentiate it using chain rule, 3 remains as it is, -1 comes down, 2x plus 5 power reduces by 1. Don't forget to multiply with derivative of bracket, which is 2. So now we have this 3, we have -1, we have 2, that is -6. And this thing over here, 2x plus 5 raised to power of -2 has to be taken down. So let me write it down. And let me draw a straight line. So therefore, this is 2x plus 5 whole square. Now, this is not a quadratic expression. A quadratic is of the form, whether the completed square form, whether the general form, all this thing, if it's in the numerator, that is quadratic. But this is not a quadratic. So now what you need to do is to apply the concept of PSAE. So again, let's focus on this one, 2x plus 5, the whole thing square. So now 2x plus 5, the whole thing square, it can either be 0 or it will be positive. It will be 0 when the thing on the inside is 0. What will make it 0? X is -5/2. What is the domain? The domain is all real values of x. And except for this, because this will make the denominator 0, function undefined. So therefore, this value is not part of domain. It already says so. So this value is not part of domain. That means for all other values, this bracket square will be positive, but there is something else. What about this -6? But f prime x is -6 over positive, therefore this will be negative. Since f prime x is negative, therefore the conclusion is fx will always be a decreasing function for this particular domain. And what is the domain? X is an element of real number. At the same time, x should not equal to -5/2. Is this all good, all clear? Question number 7. It's just the same thing as before, except quadratic concept cannot be applied because it's not a quadratic expression. It will always be positive, but this minus 6 ruins everything. It makes it negative. Since f prime x will always be negative, therefore fx will always be a decreasing function. Now, another question of the sort. Now it says y is equals to 3x cubed minus 6x squared plus 4x plus 2 dy by dx, the derivative, that is 9x squared minus 12x plus 4. It says show that the gradient of the curve is never negative. In other words, I have to prove that the gradient could be 0, the gradient could be positive. Yes, these two things are possible, but it will never be negative. Now, what should I do? I think I should convert it into the completed square form. Or I can just say dy by dx is greater than 0. That is also an option. Let me just do it in the completed square form. That is 9x squared minus 12x over 9 plus 4 over 9. Because maybe it's factorizable, maybe it's not. Not sure. So let me first try it this way. This is 9x squared minus 4 third x plus 4 over 9. And then the completing square method, that is 9x squared minus 4 third x plus bracket square minus bracket square plus 4 over 9. What goes inside the bracket? Half the coefficient of x, that is negative 2/3, that is negative 2/3. Rewrite the first three terms as a perfect square, that is x minus 2/3 whole square. And over here, this is minus 4 over 9. And this minus is there, that is this minus, this is 4 over 9, and this is plus 4 over 9. There is a 9 on the outside. Open up the bracket. This is 9x minus 2/3 whole square. This is your dy by dx. So let me write over here. This is dy by dx. It says a curve has this equation. Show that the gradient is never negative. Now, the domain is not given. Domain is not given. That means the domain is all real values of x. So now x minus 2/3 whole square can either be 0, can either be positive. That's perfectly fine. It will be 0 when x is 2/3. All good, no issue. It will be positive for all other values. Now, the question is not about increasing, decreasing. The question is about show that the gradient of the curve is never negative. That means the gradient, let me add a page over here, dy by dx, because this 9 is multiplying, which is also positive, dy by dx can be 0. dy by dx can be positive. In other words, dy by dx can never be negative. So far, so good. So now just acknowledge by looking at this question over here, have a good look. That is question number 11, in which domain is all real values of x. So let me write it down, all real values of x, and gradient is never negative. Gradient is never negative. That means we have proven that it can be positive or it can be 0. Just acknowledge this message so I can continue. This is one group and the other groups. Okay. Okay, question number 11 is also done. Now, slightly different question, slightly different. Now it says, it is given that fx is this thing. So let me write in the proper format, x raised to power of negative 3 minus x raised to power of 3. And the domain is x is greater than 0. So that is the domain. Show that f is a decreasing function. First of all, I have to do the differentiation. F prime x, that is equals to -3. -3 comes down, x -4. Power reduces by 1. -3 comes down, x raised to power of 2. All good, all clear? Now let me do some improvisation or some common thing. Let me take -3 common out. This is x -4 and this is x squared. Let me write this thing as -3 common. And this is 1 over x power 4 and this is x squared. This is your f prime x and that is the format that is needed. It's right over here. So now when we have this format, it says x is greater than 0. When we square something, a square of 0 is 0. Square of positive is positive. Square of negative is also positive. And that also goes for power 4. Because power 4 is square of square. Got the idea? That means x raised to power of 2 raised to power of 2. This is square of square. So the same knowledge applies over here. Positive will become positive, will remain as positive. Negative will become positive. 0 will become 0. Our domain is x is greater than 0. So domain is x is greater than 0. Therefore, 1 over x4 plus x square will always be positive because this is power 4, this is power 2. But because of this negative sign, f prime x is -3 times this positive over here. Therefore, this is negative. Therefore, the function fx is always decreasing. That is what you have to prove by making logical connections. Just have a good look at this. This is question number 13. So this is question 13. And this is about power 4 thing. And this is about power 2 thing also. So all these messages that I'm sending, that is for you to be alert and so that you know exactly what are the things through which we passed. Okay, all good. Got the idea? All good, all good. Okay. Let's have a look at this. This is slightly different from what we did earlier. Again, the domain is all real numbers. So the domain is all real values of x. Show that f is an increasing function. First of all, if x, that is 2x minus 5, the whole thing cube plus x. The question that we did similar to this, let me go up and let you know exactly where is this. I think this one. Over here, the derivative, that's right over here, that is just this bracket square with a constant. The question that we are doing right now, the derivative will have a 1 over here. So f prime x, that is 3, 2x minus 5, power reduces by 1. Derivative of bracket is 2, derivative of x is 1. This is 6, 2x minus 5 whole square plus 1. That is f prime x. Now let's focus on this. This thing over here, 2x minus 5, the whole thing square. This thing over here can either be 0, not this thing. This thing over here can either be 0 or it can be positive. No issue, because we have all the real values. That means one option is f prime x can be 6 into 0 plus 1, which is still positive. 1 is a positive number. Or f prime x is 6 into some positive value plus 1, which will still be positive. In either case, f prime x, so f prime x, in other words, will always be positive. Therefore, the original function will always be an increasing function. All got all clear? So that was a nice question. Question number 14. Now, let me pause the recording. I would like you people to try this particular question out. So the recording is paused. So now this question is similar to the previous one. First thing first, that is right in the proper order. If x, take x plus 1 up, it has a power of -1. Take the other x plus 1 up, it has a power of -2. That's the first thing. Keep in mind, the domain is this thing. Find f prime x, state with the reason whether f is increasing, decreasing, or neither. Maybe it could be neither. So now f prime x, -1 comes down, x plus 1 remains as it is, power reduces by 1, derivative of bracket is 1. -2 comes down, x plus 1 remains as it is, power reduces by 1, derivative of bracket is 1. So therefore, this is -1 over x plus 1 whole square. And this is -2 over x plus 1 whole cube. And what should I take common? Let me take 1 over x plus 1 whole square common. Let me also take negative common. So this is 1 plus 2 over x plus 1. Let me double check my working. This thing goes on the inside, that's exactly the same. This thing goes on the inside, so square, and this thing, that is exactly the same. All good, all clear? Now the domain is x is greater than -1. When x is -1, f prime x will be undefined. Because if I plug in -1 over here, denominator is 0. Reason, denominator is 0. So that's already out. That means for all other values, there is a square, there is a cube. Now that is an issue. So now if for all other values, we have a -1 over x plus 1 whole square, this thing will be 0. That is out of the question. So this thing will be positive, but because of the negative, this thing will be overall negative. What about this portion over here? This is 1, this is 2, this is x plus 1. So 1 plus 2 over x plus 1, maybe it could be negative, maybe it could be positive. We don't know. So now there is a negative sign on the outside. That is already taken care of. That is negative. Inside could be negative. Inside could be positive. Now it means that we are unsure. This negative into this overall negative can make it positive. This negative into this positive can make it negative. So therefore, it's neither increasing nor decreasing. So neither it's an increasing function nor it's a decreasing function, because we are unsure. We were very, very sure over here. That was very surety. But over here, we are unsure because one of the bracket has a power of 2, and that will be positive. But because of this negative sign, that will be negative. That is all done. But over here, we are unsure. Maybe if I plug in a value, this is x is greater than -1. What if I plug in -half? -half plus 1. That will be, but there is a range over here, my bad. So this is -half plus 1 will be positive. This will be positive, and overall over here, it will be positive. So now, hold for a second. I need to change this a bit. That negativity is not there because the domain is not all real numbers. So let me just erase this thing. Hold for a second. That means this will be positive because x is greater than -1. So this 1 will always be greater than this. Between 0 and -1, between -1 and 0, this will be positive. For all other values, it will be positive. So negative into positive over here, this product is negative. So therefore, the function is decreasing. First, I ignored this thing. I thought it was all real values. It's not all real values. This is x is greater than -1. Now, on the safe side, let's have a look at the mark scheme for question 18. That is over here, right over here. And that says the same thing. Let me just capture this image. It is decreasing. Now look at the mark scheme. Mark schemes are not helpful at all because it's not giving you any idea what is the process through which we are understanding this thing. Now have a good look at it. Everyone is very, very sure up till the f prime x. The problem starts over here. You have to take common. Otherwise, you cannot explain it thoroughly. When x is -1, f prime x is undefined, but this is out of domain. So this is out of domain. And what is the domain? The domain is x is greater than -1. Now over here, this is PSAE, perfect square algebraic expression. This is positive. Because of the negative sign, this is negative. So this thing on the outside, that is negative. Now let's talk about the inside. Inside is 1 plus 2 over x plus 1. Since x is greater than -1, therefore this thing is positive. 2 is positive. This is positive. This is positive. Therefore, the inside is positive. Inside is positive. Outside is negative. The product is negative. Therefore, this is a decreasing function. So just acknowledge this thing over there in the WhatsApp group that this is question 18, the most tricky one. Is this all good, all clear? So be very, very careful with the domain. Like I missed out the domain. So I was making a wrong conclusion. So that should not be the case. You have to keep an eye on the domain. Don't assume that in the previous question, it was all real values. So it's the same thing over here. No, the domain is x is greater than -1. Now let's do this last question for today. And yeah, I think I shared in all of them. Okay. Now it says question number 19. It says the function f, where fx is such and such. So let me write over here, fx is equals to x cubed minus 3x squared plus 7x minus 8 is defined for all real values of x. Find f prime x. So f prime x, that is 3x squared minus 6x plus 7. State with the reason whether f is increasing, decreasing, or neither. This is x is an element of real number. X is an element of real number. It means all real values of x. Now we have this thing. Again, let me do the completing square method. This is 3 because out of the completing square, we get the perfect square algebraic expression. So this is x squared minus 6 over 3, which is 2x, and this is 7 over 3. This is 3x squared minus 2x plus bracket squared minus bracket squared plus 7 over 3. What goes inside the bracket? Half the coefficient of x, which is -1, which is -1. Rewrite the first 3 terms as a perfect square. So these are the first 3 terms. We write it as a perfect square. So this becomes x minus 1 whole square. X minus 1 whole square. Don't forget, there is a 3 on the outside. And this is -1 plus 7 over 3. So let's multiply it with 3. This is 3x minus 1 whole square minus 3 plus 7. This is 3x minus 1 whole square plus 4. This is f prime x. It says it's for all real values. Again, the focus is on this one. that is x minus 1 whole square. This thing can be 0. This thing can be positive. We cannot say it's out of the domain. Yes, it's a possibility for x is equals to 1. It can be 0. It's part of domain. If it's part of domain, therefore, f prime x is 3 into 0 plus 4, which is positive. And over here, for all other values, f prime x is also positive. So it's positive in this scenario, it's positive in this scenario. Therefore, overall, f prime x is positive. Therefore, the conclusion is what? The conclusion is fx is an increasing function of x. Let's also have a look at this marking scheme. That is question number 19, so that we can have a good idea what can you expect from the examiner. Now, they have written this thing, that this is 19 over here. And that is the working that they have shown. Actually, there is one more question, my bad. So there is one more question over here. I need to do that. And that's very, very important. So now over here, it says we change it into the completed square form. And it just says hence increasing. Again, no logic given. So don't expect logic from the examiner. That is what I'm here for you to make you understand everything. Now the last question, question 25. fx is given as this, and now it says for x is greater than or equal to -2, that is the function, determine showing all necessary working, whether f is increasing, decreasing, or neither. So this is just like this particular question that we just did. I think there should be another one. Yes, this is the important one. The function f is such that fx is such and such, x is greater than n, where n is an integer. It is given that f is an increasing function. Find the least possible value of it. So I like this question. fx is 3x cubed, -3x squared, -9x plus 2. f prime x, that is 3x squared minus 6x minus 9. And now let's find the range of values of x. So f prime x, it says that it's an increasing function. So f prime x is greater than 0 because it's an increasing function. 3 common, x squared minus 2x minus 3 greater than 0. X squared minus 2x minus 3 greater than 0. I got rid of 3. X squared minus plus x minus 3x minus 3 greater than 0. X bracket x plus 1 minus 3x bracket minus 3 bracket x plus 1 greater than 0. X plus 1, x minus 3 is greater than 0. There is no unknown over here as such. So that's the x-axis. That's the graph. These are the values. Plus 1 becomes -1. -3 becomes +3. We are looking for greater than 0. That's the region above the x-axis. Two separate region, two separate answer. X is greater than 3. X is lesser than -1. Now they are asking for this. X is greater than n. So this is like x is greater than n. It is true for all values greater than 3. So this is 3, 4, 5, all the way till infinity, out of which is the least? So the least value of n is 3. Now, if the question would have asked this thing, let's say for x less than m, so I would compare it with this, x less than m, and they would ask us find the greatest possible value of m. So now this is -1, this is -2, this is -3, all the way till -infinity, out of which one is the greatest? So the greatest one is -1. This is the greatest one. And over here, let me draw the number line. That is 3, 4, 5, all the way till +infinity, which is the least one. The least value is 3. So that completes this lecture. on increasing, decreasing function. Hope you enjoyed the class. See you in the next session. Take care, everyone.